Good afternoon, everyone. I again welcome you to the next sessions of Introduction to Machine Learning. So, in last class, many of you were asking about questions when we have raw data or something related to EDA, that is exploratory data analysis, right? So, in this session, I will try to cover that up. So before going into that, I would like to show you how that questions can come. I'll show you a very basic question that how a question can come, and that this question have actually came for my assignment purpose. So first few minutes I'll deal with how to see for the first most important thing when we deal with our data is to know. I'm sorry to interrupt. Am I audible? Please, someone can confirm. I just started speaking. Uh, yeah, okay, great. And in between, if you guys have any question, please do speak up instead of writing in chat because I may not be able to see the chat, okay, when I'm sharing my screen. So, yeah, getting back to it. So, firstly, I would like you to know what kind of questions will come when you have to deal with your data. And this is a very real time questions which you will be given up, and based on that question, that need of what you need to do, how you are going to proceed with your pre-processing of data and then modeling of data. So today I'm going to deal with both of them. So okay, let's begin. I'll share my screen. Yeah, just please confirm if you can see my screen. Is my screen visible? uh,
Yes, ma'am.
okay, great. So actually this question
Yes,
came.
ma'am.
Okay, thank you. So this question came for my assignment when I was learning introduction in my college times. So the question was something like this. If you can read it, it's a big question, but don't get scared of the question because when you read it, it's nothing. It's just normal question which you have to figure out what things needed to be done. So the question is like you are a consultant at KPMG Denver, some company, assigned with the task of analyzing flight delays for the airport authorities. So this is a real-time question which we are going to deal with today. So the task of analyzing flight delays for the airport authorities to assist them in revamping their operations. Predicting flight delays can be useful to a variety of organizations, airport authorities, airline aviation authorities. At times, joint task forces have been formed to address the problem. Such an organization, if it were to provide it ongoing real-time assistance with flight delays, would benefit from some advance notice before flight delays to be delayed. The outcome of interest is whether the flight is delayed or not. Delayed means more than 15 minutes late. So they have specified how you're going to mention when the flight is delayed. Okay. Our data consists of all flights from the Washington DC area into the New York City area during January 2004. So they are providing the data. So like mostly it is not our job to get like scrapping out of data or data mining is a totally different, again a totally different domain to work on. We as a data analyst, what we do is we have to work with the data provided, what information we can retrieve, and the information that is needed can be retrieved or not. That is what data analysts do, and that is how machine learning come into role. Okay, so we'll not get to into the picture how the data is coming. We have a data. Okay, so this is what they're telling about the data. The percent of delayed flights among these 2201 flight is 19.5%. The data were obtained from, they're telling from where the data is obtained. You decide to interpret the problem as a machine learning problem and define the goal as to predict accurately whether a new flight not in this dataset will be delayed or not. The outcome variable is a variable called flight status, coded as delayed or on time. So this para is what the question is. So it is saying that our goal is to predict accurately. See, we have the data, we can work on that data. So that is what from the very first class I have been telling, right? With linear regression or logistic regression or any kind of other SVM we deal with, we can model our data, we can train it, test it, everything. But if the model is performing accurately or not, when we know it, when we are taking a different data set or different, the data which is not in the data set which has been provided, and it is guessing it accurately. So this is what it is telling, ki we have to predict a new flight which is not in the data set, and the outcome should be a variable, that is flight status coded as delayed or on time. We will see what it is exactly, what coded means and what does everything mean. Let's just go with the examples. Through this analysis, you want to provide your recommendations to the committee, which is not an expert in machine learning. The objective of this assignment is to understand that a ML, machine learning model with high accuracy, is not is often not the only objective, and qualitative analysis is required and reported for ease of understanding. So it's not necessary that you just have to do the machine learning model. We have to do the qualitative analysis. What qualitative analysis is, we will go into that. So they have shown the sample of data set. So this is the data set you have. Okay, that's what. And they have given the description about day of the week, how it is coded: 1 Monday, 2 Tuesday. So if you'll see in the data set, we'll go into the data set as well. So days of the week, these are coded, right? So they're telling what does this code means. So 2 means Tuesday, 3 means Wednesday, something like this. And these, I will go through the data set in the exam, like our code itself. So they have mentioned everything. So the first question is, show visualization to explore the data set and understand the underlying trends, often called exploratory data analysis, which so many of you have asked about to deal with EDA. So this is what. Choose visualization methods you think best represent the data: bar graph, pie chart, scatter box plot, something. So this is my question one. So now let's go to the question one. Before that, today I am not be able to work on open Google Colab with you guys simultaneously, because this question is long back, which I have worked on, I think 2 years back if I'm not wrong. And unfortunately, how much I tried, I was not able to find the data set which is on which I have worked this. I was not able to find it. So I already did that coding and everything when I was doing this assignment of mine, and all the codings were uploaded in my GitHub. So fortunately, I'm having those GitHub even with the results. So I can just discuss with you guys today how the exploratory data analysis is done, how the modeling is done. And it's not necessary that you have to do it for the same data. This is just an example, and I hope like there won't be an issue for that. So yeah. So the first question was what? In the assignment, the question they were asking is the visualization. So how we can explore the data set, and what are the best methods we can visualize the data. So that was our first question, right? So I'll share you my GitHub account as well. What you can do is, if you will go to just Kaushiki, like if you'll go to GitHub, just you have to make an account. GitHub is GitHub. This, I hope many of you know it, but in just in case if no one knows it, I'm again repeating it. So GitHub is github.com. GitHub. It's an online platform where you can, it's an open source platform to be said in a way. So in this, you can post all your codes, what you have been working on, and what benefit you will get would be like, if any person wants to refer your code, or if they want to see how they can make any changes to your code or anything like that, that can be done. So it's a great platform for all the coders. So what you can do is, you can just log into github.com, and over there you can search my profile, that is Kaushiki 4596. This is one. When you'll go there, you can get so many codings which I have uploaded. In that, you can go to flight delay prediction, and this is the code you will get it. Okay. And to again see it in future, you can star it. This is something called star. So if you click on it, this will get starred in your account. Okay. So, okay, getting into the code. So the first thing was to do the visualization. So again, am I have called all the necessary, and I'm so sorry that I will not be able to simultaneously run and show you. But if you have any doubt in these code, you can please ask me anytime. Okay. So yeah. So, firstly, obviously, the first step would be like I always prefer to put the first block, dedicate the first cell of my program to all the libraries which I have to use. And it's not necessary, again, I'm repeating this, it's not necessary that you have to put all your libraries at a time, because that's not possible. You don't know what kind of library is going to be used. So keep it the first cell for that, and keep adding it. And whenever you add a new library, make sure to run it again. Not the whole cell, but at least this cell which the new library has been added. So I'll not go into the libraries because most of the library we know, and whatever we don't know, we will come back again. Okay. So this was the data set, and I was not able to find this data set, so I cannot simultaneously do it because there is no point. So yeah, again, df1 is just a variable which I took. Pd is my panda again, and this is reading this csv file, .csv file. Okay. And in this, what I'm doing is, remember, whenever we were dealing with, I have told you we can visualize the data, right? Like, not visualize, I should say. We can see what kind of data we have. So what was the function? Dot head. So dot head, so starting of data. Dot tail, the last data. In this, I wanted to see both starting and end. So this is what we can write. Df1 is this variable dot head 3, starting 3 data, that is 0, 1, 2. Dot append means to sum up or to joint it, to jointly show me head as well as tail is again the last three data. So this is the data set we have. So in this data set we have some departure time, some carrier is this, these are the codes. OH DH is the airport names, right? So how Bombay is BOM and something like this. So departure time, destination, so this is JFK. So these are different airport names, uh, short forms. Distance, distances from OH to JFK, what is the distance? Flight date, flight number, origin, weather, day, week. So again, coded means 4 means my 1 is my Monday, so 4 will be Thursday. Okay, something like this. Day of month. So what is the day of the month? First month, second, third, something like this. So 31, right? And flight status on time. That's it. This is the data, and this is the data which has been just provided you. This is a raw data. Now you have to do everything from the scratch, like what you need to find. So first assignment question was to visualize what we can visualize out of this data. So let's do what all things we can think of out of this data. Okay, let's go with that. So first thing is this cell is nothing but since I have put my data into the drive, which still I was not able to find it. So this is just to mount my drive, Google Drive, onto the collab, so that directly from Google Drive I can fetch my data. So it's not much of important. So yeah, first thing we have to, we got the data, we know what all the data elements it is having. So first step is to see the shape of the data. Shape means how many rows, how many columns it have. Okay. So and this df dot is na bracket dot sum means if there is any null value, tell me how many null values are. So this line returns the sum of all the null values. So these are my rows, right? All the, like, what are the elements in my data we're having. And this 000 means there's no null values in it. But in case if there would be some null value in any of the rows or column, then they would have given us number like 3, 4, 5. So if something, like for example, if flight number is 10, this means there are 10 rows which have null values. Okay. So what we can do is we can now pre-process that. We can remove those null values. Okay, it's just like dot drop is there, you can drop it, you can remove those null value. Okay, or at least we'll be aware, okay, this have some null values. So this is the column which we have printed. We already know, we have seen this. Now what I want is, carrier was in codes, right? So this is the carrier is in code. What is the code of this? This is more of like the flight like airport, this codes were there, right? Ki, like which kind of airline it is. So that is my carrier was. So what I did was I just searched online ki what are these. So this is very inconvenient to know what is UADH. So what I'm doing is I'm just replacing this dot replace word is to replace these terms. UA to United Airlines, DH to Airlines, US to something like this. Why? Because this will be convenient for us, right? To know, okay, this is like how you are going to remember all the codes. If I have to show to someone, this will be more easier, right? So now I want to represent my data, I want to show people what kind of uh, like data we have. So the first step which we are dealing it, visualization, that should be very clear. Okay, to what all things can be done and what all things cannot be done. Okay, so now I am plotting a figure because this visualization is all about what all things can be done and what all things cannot be represented. That's it. Okay. So I'm plotting a figure, and what I wanted on figure is to show the carrier total. So what I'm showing is total number of flights per airline. Flights per airline mein I'm showing in one axis what kind of carrier it is, and that carrier or that particular carrier, how many number of flights does it have. Okay, so this is what I have represented. It's something I have just taken two column. In that two column, one was carrier, right? And the second was number of flights, which is already in my data set. So this is how I have visualized it. Okay. And remember, I've told you about an SNS. SNS is one library by which you can visualize the data very nicely. So just this is total number of flights per airline, number of flights. So it is showing how many airlines every airlines have, how number of flights does every airline is. So from this data you can easily tell, okay, Dorian Air has maximum number of flights and PSA airline is least number of airlines, then United, something like this. Okay, this is one visualization we can do that. Now the second question is, and with the graph also we are not able, so I wanted to know the value of count. So this is 551 airlines by 551 flights were by Donia Airlines, something like this. We got the data, we just did the value counts. How we got this data? Df1 dot carrier dot value count. So this value counts give all this data. Okay, now I further want to do like represent my data further. So what I'm doing is I'm making one more like changes in my data. I want to know the flight status. Okay, so I'm making a flight status, and I'm telling if my flight status, we already have flight status this, right? Flight status, on time, right? But we cannot do the visualization based on this flight status. We want to convert it into binary, either 0 or 1. So what I'm telling is, if the my flight status is on time, append it as 0. If it is like or not on time, like I delayed, it is 1. So how this on time status is there? It's already given in the assignment that if my flight is delayed less than 15 minutes, it is on time. If it is delayed after 15 minutes, it is delayed. Okay, less than 15 minutes, it's not delayed. So what I have done is I've just told if it is on time, append it as 0. If it is delayed, append it as 1. So flight status binary, I am again putting it in my data. So how I can do that? I'm putting that in df1, make a column called flight status binary. In flights, like flight status 1 was my, I have made this one empty list. So whatever they were doing in this, now they were putting all the values in flight status 1. Now there should be a column named flight status binary and put all the values of flight status 1 in that in series. So dot series means this series, that should be in series, not like 00000, like in one way, like in horizontal way. No, in a series it should be. And I'm again saving my file to in Drive. So my data was having flight delays, right? So I'm saving it as flight delays.csv again, because if I'll not save it, I'll not be able to again read it. So firstly, I saved it, and then now again I'm reading it. df1 is equals to, now I'm reading the new file. What is the change in that? This flight status binary, which put we have put it into our data. We can do this as well. So why do we need that? For certain visualization process, or we want to see how we can do that, right? So with this addition of extra column which we have done on the basis of this flight status itself, what we can interpret is, I wanted to see how many flights are there which are on time and how many flights are there which are delayed. So this is what I did, a prediction flight status into, like, to know the count. Okay, so I can even know the number of count as well. This is just a graphical representation. Dot value counts, what I have got, zero zero, what was representing zero, my, if my flight is on time. So 1773 flights were on time and 428 flights were delayed, because one was for delayed, right? Am I clear till now? Okay. So this was for whole flights. Now I don't know which kind of airline was how much delayed or something. Now I can even know which airline was on time, and how which airlines are delayed, right? So now I wanted to see which airlines were having maximum number of delayed flights. So I'm writing, what all things I would be needing. First is carrier, because carrier is telling which kind of airlines is it. And second is, what we can know is this flight status binary which we have created, right? So this what we needed. So that is how I am representing this. So one axis is my carrier, and one axis is my number of flights. So number of flights is telling, like, the Onion Airlines is having maximum number of flights, and that is this airline is also having maximum number of delayed flights. Yeah, someone is speaking, saying, is someone saying something? Going ahead. So this is another kind of representation that we can see which airline having maximum delayed flight. Okay, one representation. What now I did was, I converted my delayed flights into percentage. Why? We'll see further, like what we can use with that. So what we saw is 80% of the flights are not delayed, are on time, and 19% were delayed. Okay, so this is just prediction and visualization of data, what all you can do. That's all things we are doing. Now what we can do is, we can now finally find, if we have to put a cutoff, like if after this after this cutoff, these number of flights which has been delayed is maximum. Okay, so here what I'm doing is, I'm creating two group. One I have told test one, in which I have taken the carriers. Second, I have created test 2, which I have taken the total flights. Okay, I'm appending them, and here I'm creating one more, row, which is percentage delayed. So how we can calculate the percentage delayed? Flight status binary we already have, that is this what we calculated above, into 100 divided by total flights. So this will give me my percentage delayed for each flight, for each airlines, I should say. Okay, so we can know. So if this is the again data which I just wanted, so this is a chunk of data which I have extracted from all of my data. It's not necessary that you have to keep going on with the same bulk of data which has been provided it to you. You can just took out few rows and few columns, and you can work on a certain row, a certain column, at which you think you that can be worked. So this is what I wanted to show. So in this, what I have done is, I wanted to know my I just took the carrier row column from my data set. Delayed flights we already calculated. We have total flights. I have calculated percentage delayed. So for all of it, I have calculated the percentage delayed. So how we calculated total flight is there. That's what I'm saying. Flight status binary. We already have that 80% of flights were delayed or not, right? Or something like that. We have already calculated 0, 1, 0, 1 into 100 divided by total flights. So we got percentage delayed for each flight. So each flight is having certain percentage delayed. If this is done, then further processing, the further visualization is easy, right? So total number of delayed flight for all of them is 428, right? Okay. So now I wanted to see which each flight above what we saw it was number of delayed flights. How many flights were delayed by number? In this, what I'm showing is by percentage. So how it is useful? Because if you're telling if I'm giving you a data, okay, and I'm just telling you like a data fact, right? If I'm telling you in India 220 people are always affected by some accident, you'll not know what 220 people out of what number of people, you don't know, right? But if I would say in India 20% of deaths are being done are because of accident, you will get to know, oh, okay, 20% is out of 100%. This means the whole Indian population is being considered almost. So percentage have already a very different impact. So that is why I again did the same thing, but in terms of percentage, and that was the main aim of this. So what I did was, and I'll tell you what this red line is, okay? But first, forget this red line. This mm, this graph is just about the carriers, what kind of different airlines is, and what is the percentage of number of like percentage of flight delayed. Okay. Now what I did is this red line. I'll tell you. If you will see the third line of this, which I have highlighted. So remember now, if you'll go to the assignment, this was something called, it was mentioned in the assignment itself. So it is written the percentage of delayed flight among these 20 flight is 19.5. This, remember, you there's some data they have provided, right? So I just wanted to see how many delayed flights are there. So you this what I've done is after a certain range, how many delayed flight are there? You can change it at whatever thing you want. So what I did was y is equals to 19.44 I have taken. X minimum minus 1, that is not required, and X maximum should be 18. So what are the percentage of flights which is more than 19.44 delayed? So this is what this line is. So I have given it as
Excuse me.
color. Yeah, please tell me.
Excuse me. How you are taken? Is there any criteria for taking selecting that Y, that 19.44?
Yeah, that this is in the assignment they have mentioned now. Okay, there are two ways which I have taken. You can take any
Okay.
number of times. So if over here this was the percent of delayed flights among these 2200 flight is 19.5%, right? It is given, right? And again, if I'll go back, when where I have calculated the percentage. Okay, just yeah. If you go back, this was this, right? 19.44. Can you see this? When we
Yes.
calculated
Yes.
the
Yes.
binding
Yes.
line.
Yes.
Yeah.
Okay. Okay.
So
Okay.
this was my criteria. That depends on, and this is not needed. What I wanted to see that after 19.44, I've kept Y is 19.44. How many delayed flights are there? How many airlines are there which is crossing this red line? Okay, that's it. So this was just data which has been provided. We wanted to see what are all flights which are crossing this red line, that just analyzing ke liye, that is very easy for us. So something like that I just wanted to see. So this is what extra I have done. Okay. And this what I have done is, again, uh, we were having day of month, right? So every day of a month, how many flights were going, we were having that. So using that, I again did something like number of flights every single day of a month, which means second of any month, like take it as, okay, 2nd of September, how many flights has been done? 3rd of September, how many flights? So something like this uh, prediction, not prediction, sorry, visualization I've also done. This is all about visualization. This is out of your given provided data, what all things you can visualize. Okay. And this I have done in ascending order. The same thing over here, I sorry, descending order. Okay. Which month, day of the month is having maximum number of flight. So that is 26th of a month. That can month be anything. Have maximum number of flights. Okay. And this what I have done is I have calculated what are the top three destinations. How we can do that? We were having origin, we were having destinations, well, information as well. So what I did was I just calculated which is the maximum place, destination place, which is having maximum number of flights. Right? That's it. Like these two data I needed, the destination and the number of flights at that destination. So using that, I got to know that my okay, over here I have not used the uh, carrier which I have introduced. So these three carrier flights are the top three destination cities. So this is just the visualization what we can do out of this data. One part of my assignment is done. Right? Now let's get back to another one. So the next question was, let's go back quickly because we have not much time. Okay, so the next question was, pre-process the data set to remove null values, generate dummy variables, which we already did in our visualization as well, and divide the data set into 60% train and 40% test. Prepare a logistic. They see in this only they have mentioned how many training and testing data you have to do. Prepare a logistic model that can be obtained accurate classification of new flight based on their predictor information. Okay. So these all things are there. Interpret the model and coefficient and present some insight. Perform variable selection and reduce the size of the model, only keeping the relevant variables based on an analysis done. I'm just reading this question because everything I've done in one go itself. So that would be easier. Conclude the analysis by fitting a new model and deselected variables and report the same. Find the ideal weather conditions for highest. These are all questions can be there when you are working with our data. So these questions can come, and then you can do according to that. So this is I have done the pre-processing of data, what all information can be changed, and what all information. Let's go and do one thing. I have done in flight modeling as well. I have done the pre-processing, so it's fine. Let's directly go into this. It's fine. Okay. So let me see. Yeah. Okay. Yeah. So now again, I read my data, uh, like calling the libraries, reading my data. So this is the data which I have already, improved it. How I have improved it? Remember this flight status binary we created in visualization? It is here, right? So I've saved that data and I'm calling this that data itself. Okay. Again, this carrier has been replaced by this airline's name, everything. So this is the data which I have got. And yeah, so over here what I'm doing is I am, if someone want to say something, please do tell me, like unmute yourself and tell, because I'm not able to see the chat. Okay, just in case. Okay, so what I want to now do is I want to see how, like there's something called departure delay. So I wanted to see what are the, like how you're going to know if flight has been delayed or not delayed, right? So we in this data set there was one more thing mentioned, that was departure time and arrival time, if I'm not wrong, if I'll go that. Yeah, departure time and arrival time, there is something called that. So based on that, yes, see, this is there na, CRS departure time and departure time. So what is the actual departure time and when it actually departed, something like this. Okay, so with the help of this we can know if the flight is delayed or not. So what I am in this, what I'm doing is I'm just doing the calculation what the departure time is, that is actual departure time that needed to be done, and what is the departure time when it the flight actually left the origin. Okay, so for example, if your flight is at 4 o'clock but it is departing at 4:15, so you can tell, right, that 4:15 minus 4, that is 15-minute delayed it is, or 4 minus 4:15, whatever it is, you can know what the. So that is how I've calculated one more row, that is departure delay. Okay, now what I'm going to do right now is I'm going to remove whatever things that is not necessary. So in analysis or any kind of prediction, flight number is not necessary. We don't need flight number. What we can do with the flight numbers, we have the like, destination, origin, or carriers. We can say, okay, Air India is the most delayed flight. That kind of prediction we can do. We cannot say Air India with this particular number is the maximum. That doesn't make any sense, because no one remembers uh, like what kind of flight number that flight is going to. Maximum what we can do is, okay, Air India with Mumbai to Delhi flights are having maximum delay. That analysis we can do. So at least we would be needing either origin, destination, or carrier name. There's no need of flight number, so we are removing it. So this is how we do is dot drop. Okay, now again, whatever we will drop, we want a new data, so I'm again saving it the new data. Now I need to know if there's any number that is missing. Okay, so how we can do is dot isna dot sum tells returns the null values, and dot sum gives the sum of those null values. So we can print that. We can print the shape. And I don't know, I'm so sorry that this has been not run. So yeah, there was no errors, nothing was there. And they see, dot fill na 0. So if there is any, for example, if I would have run this line, okay, and if there was some rows or columns which was giving some, like I told you, for example, flight delay is a column, and it is having some nan values 10, it is giving 10, yani 10 nan values it is having. What we can do is, we cannot perform our processing if somewhere some columns are having, or some rows are having some numbers, and some rows are having some nan value. Nan is a string, so we cannot work in it. So what we can do is, this is what we can do: dot fill na 0. So wherever there is na, fill that with 0 value. Okay, and then we can proceed it. So there are either two ways: either you can remove them completely, and if that removing is not an option, because that can hamper your overall data prediction, you can just fill it with 0. This is another way. Now,
Excuse me,
yeah, yeah,
I
please.
have a doubt. You have dropped that column FL flight number. After that, you have saved. Is it necessary to save or
Yeah, because,
anything further?
yeah, see,
Uh,
the thing is, you have worked on that data. You added one extra, row, column, or row.
no, actually, you're saving it in a variable FL1. So, is it really needed to save in particular location or like that?
Nothing like
Or
that.
you
What?
need that,
Okay.
or
So
you need that file for further processing afterwards, like that maybe.
yeah, exactly. See, the thing is, I have
Okay.
I have appended, or I have put a new column in my data. So first I need to save that data again, because if I'll not save it, for example, and if I'll not save that data, and I'm going to again call it, so it will give me my original data, right? If I'm going to call, for example, if I would have not saved the data that I have added these things, remember in visualization we added this flight status binary. Over there, if I would have not saved it, and then over here, if I would have called this without saving that data, then there would not be flight status as binary. So there was no point of working over there, right? So if you need, like, you don't need to again and again do the same thing. So if you feel this, I felt that time that flight status binary, which I have done, would be used further again for my other process. So I just saved this data and again call, when I'm calling it, it is already having it. So that is the use of saving it. Okay.
Actually, but that
Yeah.
variable we are saving it in a variable, we can use that, right? If,
Yeah, you can
I
do
don't know,
that.
but
What you meant is you want to save it temporarily and not save it permanently, right?
okay, 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 okay. Uh-huh, uh-huh.
Yeah.
Uh,
Yeah, obviously.
By doing that, you're saving that it's just you're saving it in the hard disk or something. What you
You can
I
do
did,
both of them. You can do both of them if you want to, save it like permanently in a drive or something. You can do that. You can
no, what you're doing there, df1 df1.2 underscore
CSV. Okay,
cvs.
so what I am doing is I already have a flight delay dot CSV file. I'm just overwriting it.
Oh, okay. Oh, okay, 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 okay.
Yeah,
You're overwriting. Oh, okay, okay. Same
exactly.
location you are given there.
Same
Oh, okay, okay.
location.
Oh,
I'm just
okay,
overwriting
thank
it.
you.
If you
Oh,
want,
okay, okay.
you can just change this name. Flight instead of flight delays, just write the updated flight delays and then save
Oh,
it.
got it, got it, got it.
Got it?
Okay, okay,
Yeah.
okay. That's okay, okay.
Yeah. Okay, so all these is done. I told you how you can remove the any values. Now what I'm doing is I want to like know what day month it has. These same way values are there. I want to know what are the maximum number of days in a month which has shown total number of month. Okay, so I'm sorry I cannot show you the output of it, but yeah, let's like try. I'll try to make best out of it so that you can understand how you can work on the data set if you have given us some certain data set. Okay, so okay, finally, what we already have calculated this as well in previously, so let's not go into this. This is this flight status binary values, that is 80% of the flights were on time and 19% were on delayed. That was it. Yeah. So over here, what I'm calculating is I'm calculating the value counts for weekday, which means, for example, 4 is my for Thursday. So on Thursday, 391 flights are there. On Wednesday, 372 flights are there. Something like this. So in a weekday, with weekday wise, how many flights are there? So what is the use of that? We'll see. How we are going to work on that. Okay. So this is the data set route right now we have. Okay, so total number of departure origin cities, total number of arrival destination cities we want to know. So I have calculated the top cities. I have calculated the how we can calculate the top cities, because we have to see which that we have already decided like discussed, that which destination is having come maximum number of flights arriving. That's it, right? So moving ahead, yeah. So what I'm doing is I'm again like these all, what I have shown you right now is not a well organized Python code, I would say. So this is how we work actually. Like even I was like, this is my assignment which I'm showing to you. To be honest, this is actually I have worked on it, and that time I was just running. Okay, what can be done out of this? What is if I have to take out this? What values I can take? What all things I can work on it. So something like this I was working, and this is the result of these all again and again df1 dot head dfm dot info something else. So what one thing I have interpreted is there's no use of this much of data if I'm going to work, right? If I have to predict if a flight is delayed or not, what all information I need is was in my mind, right? So if I'll ask you, looking at this data, like if I'll just look at this, yeah, this data. If I look at this data, I can someone tell what are the information which will not be needed if I'm going to do any kind of prediction, or prediction in knowing if a flight is delayed or not. So what all information is not needed? Can someone tell? Quickly, quickly. It's just, kind of common sense. We can say, okay, these information is not relevant or something like this. So can someone say,
Month, date,
sorry, what?
month, date.
Exactly, exactly. It doesn't matter flight date. So there's no need of flight date. Similarly, this tail number. Tail number is something, the flight number, you can say. There's no need of that, right? Something like this, these all information is not needed. So why do we keep it? What is the use of it? So let's just drop from our data. So this is what I did. I have removed flight date. I have removed month AB. Month AB is which month it is from. We don't need January में इतना हुआ, February में this much flight delay. There's no need of that, right? So these all three information, I just removed it. I don't need it. Okay. When I removed it, I have certain data, and what I'm calculating over here, df1.core, is correlation. So I'm just finding out statistically. Okay, so there was something I forgot to show you. I have used one library. Okay, not in this, I guess. Okay, okay, maybe it will come later. I'll again introduce you. Okay, so what I have calculated is, I have calculated the correlation. So what correlation is like, every departure time, distance, what are the correlation between the data, that's it. It's statistic interrelations which is needed sometimes. What we can say is, month and month is nan. Why? Because month is what? Numerical value, right? January, February, or something like this. So correlation is what? Your statistic numerical value, which does the covariance or standard deviation. There should be some numerical value. So that is why month is giving nan. So again, I realized, oh, I didn't remove month. There is no point of that. So I just removed the dot drop month. I don't need it as well. So I removed the month column as well. This is where we need our correlation things as well. If I'm missing something out, which I was not able to understand that time, oh, there's no use of this column as well. Over here, something, when you do some statistic thing, you can realize, okay, there's no need of this as well. So I just remove the month. Okay, now this is my data, what I have right now. These all information I have. Using this all information, now again I have to do some prediction. So yeah, this is some heat map I have generated, which you cannot see it because it's not run. I'm sorry for that. So final, this is my data, which is again I've shown. I'm again removing carrier, destination, origin, flight status, because I thought, because there's no use of that. Flight status, there's two type of flight status and flight status binary. Flight status binary is 0 or 1. 0 on time, 1 is delay. So if I already have flight status binary, there's no use of flight status. Destination and origin are all again in what? String values, like JFK or whatever it is, or carrier, again the airline. So these all things are not needed if I'm going to do the prediction. So what prediction or any logistic regression, linear regression is mostly is done with the numbers, right? So there's no use of these things. So I don't need it. So I removed it. Again, what I saw is, there's some column abruptly that can happen when you do so much of pre-processing. There are so much of chances that suddenly a column will come up with some error. So this what I see, that unnamed zero, that suddenly came out, some error or something like that. By itself it came out, I don't need this as well. So I again dropping this as well, right? Unnamed zero. So after all this, you have to do a lot of time, these all things. You get this value, this data set, you got the information. You, this dot info will give everything. Ki what are non-null points, non-null count, what is the data type of that is integer, everything. It is showing that what is the memory uses of this data set, everything. It gave everything. Okay, till this point, what I have done is just the pre-processing of data, visualization of data, interpretation of data. That's it. Up like till now, from before today's class, whatever I was doing was, till this point of time, almost everything was done, and we just needed to do the modeling of data. Today, I told you how, what are the steps of pre-processing and visualization and interpretation of data. From this point onwards, again, we are going to the same things we did from last 3 4 classes, that is modeling of data. That is now our machine learning comes into picture. Till now, we have not done nothing of machine learning. Okay, now I have to do the prediction. So my y, that is output, is flight status binary. That is our ultimate goal. We need to know if my flight, if I'm given certain information, I just need, user just need to know if a flight is delayed or not. Our thing is to let user know in a very convenient way. So our output is flight status binary. That is, flight status binary was a column which we have created, which says if it is coming 0, it is on time. If it is coming 1, it is delayed. That's it. Okay. X is what I'm giving is, since I have pre-processed data and I need this many information to do the processing, except for flight status binary. That is why I've written dot drop. Except for flight status binary, take whatever information there now in the data. So whatever information is what? These all information that we have already created. Okay. The final data which you have created in numerical values. Okay. So this is what X and Y is. I given that. Now again the same thing come trend and train test. I'm calling train test. Okay. Everything is giving yeah. So I'm doing logistic regression, fitting X train, Y train, all these things are done. So this is the output only. This, don't worry, this is nothing. I have not written this, which I have done this underline. This is when you will import logistic regression, and when you will do the LR fit. This is the output you will get. It will tell what all things logistic regression is having. Okay, and I need to know the score of my X test and Y test. So it is coming 89% C, right? Accuracy. I need to now predict the training and testing. I need to do the accuracy score, right? So how we can do is F1 score, confusion metrics. There's so many things we can do, right? So these all things I'm doing, like I'm printing what kind of model it is, I'm printing what accuracy it is, what F1 score is. So this is what it is showing. Logistic regression for training matrices, it is giving accuracy 90% and F1 score 67, while for testing it is giving accuracy 89% and 68%. Okay. Okay, I even calculated the confusion matrix with Y test and LR test to do the prediction. So this is true positive, false positive, true negative, false negative. This is my what? Confusion matrix. And this is the classification report. Like last time during SVM we also saw. So this, we have two classes, 0 and 1. 0 is my on time. So for on time the precision is 90%, right? And recall is 98. So this is pretty much, remember we last time we saw how we can visual I mean we can interpret if a classification report is good enough or not, right? S- with this we can see accuracy is coming approximately what 90% is. Macro average 89, weighted average 90. My precision is good. My and for both 0 and 1, for both my precision is good. My recall is good. If if for one it is not good, then even prediction of delayed flight is not good, right? So my we can say with this statistical view, okay, my classification report is pretty much good. So now we can say, okay, whatever I have done, my you know uh, in machine learning, whatever training I have done, what is pre-processing I have done, I can say my result is coming good. This is something which I have done extra, which is something called Great Search CV and Cross Validation Score. So, if I don't know if you guys know about what is cross validation. I would suggest, if you don't know, please go and read, because this is more of a theoretical. It's a whole lecture in itself, the cross validation. So, in short, what I can tell you is there's something called training, there's something called testing, there's something called validation. So, validation, what we do is, in validation also there's certain kind of things. So, in validation, we keep a chunk of data aside, and we do a validation during training itself. What does it mean in training itself? I meant is, think about if you have thousands of data, and training, if you will think, oh no, first I will do, what I'll do is I'll train all the thousands of data, and then I'll predict that thousands of data on fewer thousand of data as a testing. But think about it, how much time will it take? So you cannot spend your 2 days, 3 days just in processing of your data and then doing the testing of data. What if your pre-processing is wrong, or your some error would have come in between itself? There your validation comes in. That is called cross validation. What we do is, we train a certain chunk of data, we do a validation on that data itself. Okay, what kind of result we are getting, and then further we will do again training. Okay, if we are satisfied with the validation, we'll go further and we will do the again training, and then again we will do the validation. So we are dividing it into chunks. Why it is helpful? Because if my validation results are not good, if with some thousands of data only, like not 10, like think about if you have 1 lakh data, and you are dividing into 10,000, 10,000, 10,000. So at 10,000 only you get to know, okay, there's some error because during cross validation itself my result is not coming what is needed to be come. At least you can interpret the result is coming good or not, right, with your statistical analysis or classification report, or there's so many things. You can stop at that very point. You can go again back and you can see what error or what mistake you have done. Okay, so this is where cross validation score comes into play.
Ma'am, actually, what is the difference between gradient boosting and the cross validation?
Okay, so gradient boosting is something when we work with neural network. Okay, gradient boosting comes when we work with neural network. Neural network, what we do is there's something called weight and bias, WNB, if you remember these term. So in boosting, when we go forward, okay, like when we are calculating our when we are training our neural network, that this is how you have to work, this is how you have to work. So in neural network we give some certain weight values, and we don't know what kind of weight values it will work on. It's a more of hit and trial method. So we need to minimize the loss. So to do the minimize, and these are very I cannot define every word I'm saying, every terminology which I'm using, because again it is whole together a different topic. I would love to do that, but I won't be able to cover it every time. So to answer your question, gradient boosting is something we deal with reducing this W value, that is weight value, by a certain time. We cannot reduce it abruptly because we don't know where the minimum loss is. So we decrease it again and again and again. That is gradient boosting is. Cross validation, what I'm saying is we are training our data, but we don't want to, if there's a large chunk of data, we don't want to firstly again train it completely and then test it. There could be some error. So what we do is if we have 1 lakh of data, which is a huge data, we divide into chunks, for example, 10,000, 10,000. At each 10,000, we'll do some validation at that point itself. Like with certain value we'll do. That term is not called as testing, that term is called as validation. We validate it if what training is going to be happen is like good or not. That's it. Okay, hope I'm clear. So yeah, this is what I have calculated, what my validation score is, and what my this is not needed over here.
So,
Yeah.
validation is actually used for changing the parameters like alpha and beta, right?
Uh, yeah, you can say like alpha and beta if you're talking in the terms of SVM. So yes, if you're talking in terms of generalized any model, yes, that cross validation. There's so many k-fold cross validations are there.
No, no, no,
Yeah,
not cross validation. I'm
yeah.
just saying about validation set or validation
Yeah,
set.
exactly. Yeah,
Okay.
yeah.
Okay. Thank you. Thank
Okay.
you.
Okay. So now I'm done with everything. What from like starting ahead, what we all did was the last step is left. So before getting into the last step, we'll just go back again. We did all the we got a raw data. We saw what all data we have. We do the visualization, what all things we can interpret from data, what all things needed to be added in that data to further enhance our processing thing. And then we removed certain columns, we added certain columns, we did certain calculations, everything. Then when the pre-processing was done, we are happy, okay, this is the thing which I require for further predicting a flight delay. That was our ultimate goal. Then we did the modeling of data. When we have done the classification report, uh, metrics calculation, confusion metrics, everything we done. Now the final step which was asked was, you have to predict for a certain information given, certain information has been given, and you have to predict if that data, like if that with that particular information my flight is delayed or not. Okay, that was the ultimate goal. So what kind of data set, that is not given. So what I did was randomly I gave some numbers. Like you cannot give it randomly, but yeah, you gave. So 1500 is this CRS departure time. That is the departure time which actually happened. Departure time 1725. Okay, no, like 1500 departure time is the mentioned time. 1725 is the departure time. 150 is the distance. I'm giving this data. You can give any values. Okay. 0 is weather. Again, I gave day week is 4. 1 is my day of month. This day of month. 175. Uh, 1 and 3. This value day, weekday. Okay, these all values has been given. Okay. Again, I gave again certain values I gave. So this is flight status binary. This flight status binary is what you have to calculate. Okay, this is what is my y. So this is logistic regression has given.
One
Yeah.
question. Hello.
Yeah.
Actually, how do we expect questions based on this
Sorry, what?
EDA? Is it going to be MCQs or like essay type
uh
questions, types of?
Type of question, I think you can ask like uh, people
Is it
who are
going to be
into,
MCQs
because
or
I'm not the one who
it's,
is setting up question.
yes,
I'm sorry.
yes, yes. How can we
Yeah.
expect questions?
So this is my L, okay? Now I have to do the prediction on this data which is not known by anyone, okay? So I am doing the prediction. I am doing the logistic regression. So again, I'm saying if is equals to 1, what I'm telling is if the value is coming 1, then this means flight is delayed. Else say flight is not delayed. So I'm doing the logistic regression. 1 flight delay, 0 no delay. Okay, this is 1. And I'm doing my scoring, that is this means, what does it means for this value, it is saying my flight is delayed. For this value, it is saying my flight is not delayed. And if you will remember, and you can say itself, right, by just seeing this value and this value, you can say flight is delayed or not, right? Why? Because we remember, right, if a flight is uh, if a flight departures 15 minute after its actual time, then it is considered as delayed. Otherwise it is not delayed. So what I given just to check if my model is working fine or not, right? That's what you wanted. So deliberately what I did was one chunk of data I gave the CRS departure time as 1500 and departure time is 1725. That means 3 o'clock and 5:25. While one chunk of data I told as 3 o'clock and 3:15 at the border exactly, right? So see what it is giving. 0 as no delay. This means this flight is not delayed, and 1 as flight delay. This means this is my delayed flight. Okay, this is how it is giving my prediction, and I have done the scoring to 89%. So this is what EDA I wanted to show you. I'll first share this GitHub thing. You can go in, or I can just give you this itself, the whole thing in the chat box. And yes, you can refer to it if you want. So, okay, the question was, sorry, that's what I told in the starting class. I do not work in this collab today because I was not able to find the data where it was. It was just from an assignment which I got when I was working, when I was learning machine learning. So I already have worked on it, and I wanted to show you guys how the prediction and how the data analysis is done. So one is how can we expect question based on this EDA? Okay, not necessarily that question can come from this EDA. I'm so sorry. I took this session because so many of you were asking me that about EDA and how to do the pre-processing of data, what can be done. So I thought today is the class which I can take. So I took this class. So I hope that is fine. So yeah, it may not be related to your like examination purpose, but this is how real time questions comes into. Okay, so yeah, I hope.
Madam, when you will start the machine learning algorithms?
uh yeah, we are doing it, right? Like we have done linear, logistic, SVM. Further I'll start with neural network. So yeah. Okay, then if you guys have no other question, I think let's meet in next class. Okay, bye, thank you.
Thank you.